This section is about the paint transmission grating. So what is paint transmission grating? Firstly, we can recall what we have talked about the single slit. That means we just have one slit to allow the light to pass through, so we can observe a diffraction pattern, and which we will get the central bright fringe as shown in the figure. So if we draw the relative intensity of the light, we can observe there is a central bright fringe. So in the middle is the brightest, and then it becomes dimmer at the edge. So this is what we can observe in a single slit. And in the previous section, we talked about another item we call the double slit. That means there are two slits on the first part, so that it allows the light to pass through. And as what we have learned, the interference pattern will be observed in this case. So we can observe the alternate bright and dark fringe on the screen. So you can see in the figure, then it is a very clear interference pattern. So if we draw the relative intensity of the light in this case, so you can see that is brighter and then dimmer and then brighter, and in the middle is the brightest, and at the edge is the dimmest. So this is what we will observe when we talk about the double slit, when the lights pass through it. And we have the slit separation we call the A, and we also have the delta Y called the fringe separation. And we have the double slit equation to help us to solve the problem. And now we talk about the diffraction gradient. What is diffraction gradient? Actually, the diffraction gradient is an item that consists of many slits. What does it mean by many? It's usually more than 1,000 of slits. And the pattern we observe is similar to that of the interference pattern. But the difference is the bright fringe is very, very bright, and it's a very sharp line with a very large separation. So you can see if we sketch the intensity of the light, it is much brighter than the one that we observed with the double slit, and the point is also very sharp. So you can see that the peak is a very thin peak, a very sharp peak. So this is what we can observe when the light passes through a diffraction grating. So if we compare the single slit, double slit, and then the diffraction grating, it is something like this. And we define the separation, the slit separation, as D. Okay, it's just differentiate it from the double slit. And the interference pattern formed by the diffraction grating, or sometimes you can see a term called paint transmission grating. Actually, it's the same thing. So the bright fringe are the position that form due to the constructive interference. So we have two kinds of grating in general. Fine grating means we have a small grating spacing. That means the slits are closely packed. For example, we have 300 lines per mm. That means in 1 mm there consists of 300 slits. And another kind we call the coarse grating, which have a large grating separation. So for example, maybe just 100 lines per mm, but you can still observe, even we call it coarse, but actually it still have a lot of slits. And the grating spacing increase, the number of fringe will be increased, and the fringe separation will be decreased, as shown in this figure. And when the lambda, okay, that means the wavelength of the light decrease, what will happen? Firstly, red to blue, which kind have the lowest wavelength? Okay, blue is lowest. So blue color, the fringe separation will be smaller. When the white light passes through the paint transmission grating, the fringe of different colors can be formed. So we will observe a rainbow-like pattern. In the following figures, we will talk about some more details of the observation related to the diffraction grating. So firstly, once again, we define the grating spacing as D, a small d to represent it. And there are fringes formed on the screen which have a distant capital letter D from the grating, as shown in this figure. So the capital letter D represents the distance between the screen and the grating. If we consider the nth order of light, we can define the angle theta from the central bright fringe to that particular bright fringe. So these are the values that we will use in the next part when we try to do some calculation. Okay.